Hello, today I'll talk about life cycle of stars. A star's life cycle varies depending on its mass. A star begins its life in a nebula, which is a cloud of hydrogen, helium, and dust. As atoms within the nebula clump together under the influence of gravity, a protostar begins to take shape. Newborn star. As a protostar becomes denser, its core grows hotter. Once it gets hot enough to begin burning hydrogen, it becomes a true star. Stable star. When the gas pressure generated by nuclear fusion in the star's core counterbalances the effect of gravity, the star achieves equilibrium. During this stage, the star shines as it burns its supply of hydrogen. Our Sun is in this stage. Scientists predict that it will remain stable for another 10 billion years. Red giant. As the hydrogen fuel in a star's core runs out, the loss of equilibrium causes the core to collapse. The core grows hotter as its density increases. This causes the outer regions of the star to expand and cool. Planetary nebula. As the red giant's outer layers and ejected matter disperse, they form a shell around the dying star's dense core. This is known as the planetary nebula. Now we have the white dwarf. A medium-sized star like our Sun is likely to collapse into a tiny, dense white dwarf, which will continue to glow faintly because of heat from earlier stages in its life cycle. As a cloud filled with dust and hydrogen and helium gas slowly begins to revolve around the central core, the core attracts more matter, and the increasing pressure heats it up until it becomes hot enough for the hydrogen gas to fuse in a nuclear reaction. The energy generated by the fusion reactions prevents further collapse, and the core becomes a main sequence star. Clumps of dust. Nebula are clouds of dust and gas that pervade the universe. Matter within a given nebula is distributed unevenly, and the temperature is low, just above absolute zero. At these temperatures, gas molecules bend together to form clumps, and a clump growing in a dense region of nebula called a molecular cloud can begin to attract matter toward itself. As the clump grows, the temperature at its core increases, because gravitational attraction increases the density of the particles. Now we have the main sequence star. As the temperature of the core increases, it becomes a protostar and radiates infrared light. But as the core becomes denser, the energy is trapped, which accelerates heating. Hydrogen fusion begins, and the outward pressure of the reaction balances the compressive force of gravitation. The star enters its main sequence, which can last from 100 million to over a trillion years. Formation of a black hole. When a blue giant runs out of hydrogen, its core begins to collapse, which generates enough pressure to initiate helium fusion. Other fusion reactions occur as the core continues to collapse, and at a certain point, the star runs out of material. At a critical point, the core implodes in what is called a supernova, which blows the star's outer shell into space. If the matter left over after the supernova has a mass of 3 times or more that of the Sun, nothing can stop gravity from collapsing into a point with infinite mass. This point is the black hole.